See a red light, I'm on the air. Gotta get started here. It's a busy day and I wanted to make a video about gravity. So here I am. Hi, my name is Butch Terry David Silvercloud. I'm 74 years old. Today is the 8th of November 2018. And it's been a mix of sun and clouds in Vancouver today. It's fairly mild out. It's sunny out at the moment with clouds. So I want to talk a bit about gravity, and I'm a real yak motor mouth. I am. I try to be useful in my old age I live alone. I keep busy painting, and I make videos to try and educate you humans about what's going on out there. You don't have to take my word for anything. Don't believe me. I'm a pretty sharp guy, though. You might want to listen. So there's a physicist whose name is Lee Smolin, and he wrote a book quite a few years ago now, nearly 20 years ago, 18, 20, quite a while ago, called The Trouble with Physics. Now what's interesting about Lee is that he was considered one of the leading string theorists on the planet. He ditched string theory, said, that ain't working. And he took up quantum theory, and then he went off to work and head up the Perimeter Institute of Theoretical Physics in Waterloo, Ontario, here in Canada, at the University of Waterloo. So it's a theoretical physics research area. And his thing that he was taking up was gravity, and he was trying to work out his own theory about quantum loop gravity, or loop quantum gravity. I'm not sure which, I've forgotten which way it was. Anyhow, I have my own ideas about gravity, and that's the whole point here, is that Lee in his book was pointing out that in the last 100 years there hasn't been any huge breakthrough in physics. There's been lots of gadgets, and the applied physicists, the people who take what we know, and usually they're engineers as well, turn them into useful things. They know, gee, what if we took that and did that, we could make this. That's applied physics. And then I live beside an alleyway there, a garbage truck just went by. There are people that just try to figure out how the universe works, or mostly how the universe works. They theorize, they think about things, and Lee in his book The Trouble with Physics pointed out that we become bogged down in dogma and hierarchies at universities. People that are afraid to go too far astray from accepted ideas lest they lose their jobs, and that graduates are coming out not grasping that a lot of what they were being taught is theory, not fact. And that, I don't know if Lee said this, but I'm saying it, we become bogged down in physics, weighed down by mathematics. The mathematics can come later once you have a really great idea. Michael Faraday, he was a bookbinder before Sir Humphrey Davy discovered him and got him to work for him, and so he was an idea guy, and he had really great ideas. We owe a lot to Michael Faraday. He gave us most of our ideas about magnetism and electricity, but he was only high school educated, but had quite the brilliant mind. And a lot of times, like even Einstein, he got bogged down by the ideas of his time. He did not know about waves. He didn't think of the whole idea of electromagnetic spectrum and all that hadn't really arrived yet, and quantum physics wasn't invented yet in 1916. And he really got bogged down in the idea of because light seems to behave like particles, trying to resolve a lot of that out, and so we ended up with light photons, which are not quite the same as quantum photons, which are used at the elemental level in quantum physics. A photon is a function of wavelength. It's an energy function of wavelength, and it can be measured extremely precisely because you just multiply the frequency times the Planck constant and you're there. So there you are. Every photon is dependent upon its frequency, and there are light photons and there are quantum unit photons. Back to Lee Smollett, he sort of said we need some better ideas, but the problem is the hierarchies of the university. You know, like even people who are totally wacko, some of them might be onto something, and there's going to be a whole slew of you out there that think I'm totally wacko too. They had me tested. 2 different psychiatrists have told me I'm perfectly sane, just highly intelligent and overly emotional. A bad combination, it would seem. Makes for a lot of bipolar problems, that kind of stuff. Where were I? I go on and on and on like a dripping tap. 6 minutes. Not too bad. I don't want this to be too long. So the problem is, Lee, in his quest for a solution to gravity. I think I said this. We do not know what causes gravity. We can measure it, we can predict it, but we don't know what it is. Why? We do know we can make what we call artificial gravity, and why it just doesn't sort itself out and say, oh, that's it. Gravity is motion. And what is motion? Motion is response to differences in energy. So gravity is just a response to differences in energy. And gravity is the desire of all things solid to come to rest. The entire universe, I don't believe in Big Bang. If there's Big Bangs, they're all over the place. Big Bangs are as common as popcorn. If there's such a thing as Big Bang, then literally there's as many Big Bangs as you can count grains and the grains of sand. You get the idea. Big Bang is for people that don't think things out. So the universe is an infinite soup of something, and in my world it's an infinite soup of particles smaller than the electron. So if this were an electron, I believe that the electron is not spherical, because spherical electrons are just bad mathematically. The mathematicians will understand, and I think the physicists will too, but if you're trying to resolve something, sphere is the last place you want to go, because there's infinite vertices. Where you want to go is down to the tetrahedron, which is the shape with the least number of vertices, edges, and faces. So really, a tetrahedral electron is just, that doesn't work very well for reasons I don't have time for. But an icosahedral electron would work really, really good, really well. And the reason for that is that an icosahedron is 20 tetrahedrons, all sharing the same apex. What that means is that 20 smaller particles, which we can't detect because they're just too small. If we use electrons, we can't detect particles smaller than the electron, because that is our smallest solid particle, and it's a very uniform one that seems to be indestructible. But if it were made of 20 equilateral tetrahedrons pushing against each other, once it was spinning, it would seem like a sphere. Electronically, it would be as good as a sphere, but it would be a very good fan blade. I don't know what Dyson uses, but it'd make a very efficient kind of drill bit in all directions. It would be fanning in every direction. So that would help make the electron a very good monopole with poles. It could spin, and if it were stirring up the stuff all around it, which were smaller things of which it was made, then it would be a very efficient motor just sitting there right in space spinning. So at absolute zero, we should assume that, relatively speaking, electrons are not spinning. They probably are spinning, but relatively, using rules of relativity, which I think the physicists will get, it might appear to be standing still, just like if you were riding on a bus and you saw a truck going along the highway beside or if you were on a train and there was a highway right beside the track, and you're watching a car or a truck going along at exactly the same speed as you on the train, the car or a truck would appear to be still, and it would be the land that was going by. That's relativity. Where was I? So if you can envision the problem that all things are trying to find rest and can't because there's going to be other things in the way. Groups of things like electrons will be bullies, like a crowd in a stadium, and they can push lots of things out of the way. Or where there aren't so many electrons, the point of it is, I'm trying to get across here, is that electrons, because of the fact that they're pushing either dark energy, dark matter, or smaller particles, which are the dark matter, dark energy, it's just the way it is, out of the way, then I lost what I was going to say there, they create pressure outwards. So if the entire universe is full of enough electrons, which it is, electrons outnumber all other solid particles that are stable. And there's only 3 really stable solid thingies. One is an electron, the other is a proton, the other is a neutron. A neutron is a proton plus an electron. A neutron can decay. It's pretty hard to break those suckers up, but when you break a neutron apart, which can happen in an atomic blast, it will spit out an electron, which you will think of as a beta radiation. It doesn't go very far, but it's quite dangerous. And if I tell you it's shaped like an icosahedron, which is like a drill bit, even if it only goes a couple of feet, and it's going almost at the speed of light, it'll just go right through you, and it may not hurt you, but if there's enough of them, and there are in radiation, they're going to start snipping genes left and right, and the next thing you know, you're dying of radiation poisoning. So beta radiation is just flying electrons, and alpha radiation is flying protons, which are helium, without their electrons. Seeking. You would think they would get together, the beta and the alpha, but they don't. It's complicated. Let's not get into that. The point is here, gravity is caused by all things particle trying to find rest in this ever-moving universe, which is dominated by, mostly, by what we would call dark matter, dark energy, and I'm telling you, it's my opinion, maybe others have the same opinion, of a major smaller particle, which is the gamma particle. And gamma particles are large enough that they can leave shadows, and that's the way we can detect them. We use them, like to analyze containers of cargo. We know how to generate gamma rays, and they're so small they just go right through metal, and you basically take an X-ray of whatever is inside the container. So although we can't see gamma rays, we can detect them using electronic means, which comes down to photons. They may not be big enough to be a photon, big enough to disturb film, but if enough of them hit at the same time, if there's enough amplitude, then they will leave a shadow around things that are a bit more dense. I think I made my point. 14 minutes. Where were I? So why are things in motion? Well, for one thing, let's get back to gravity, because that's what this is all about. You feel like you're being pulled down to the floor, but all that's happening is you are a hunk of material, just like this, a kind of spongy one, but you're still a hunk of material, and you're flying through space relatively against what the Earth is doing, and you have encountered the Earth. Fortunately, you didn't do it with a splat. You're here nice and soft. But if you were up in an airplane and I dropped you out, by the time you arrived at the surface, you'd be definitely very splatted. So when you were up in the airplane, in order to keep up with the rotation of the Earth, you had to move faster than somebody on the surface. And if you were going to go down to the surface, that extra speed up there was energy, and you have to give it up. So as you give up energy, one way or another, with a parachute or whatever's going to work for you, or a very long glide path several times around the planet, so you can slow yourself down enough, you have to reduce your energy. You are trying to come to rest. Could you get it? Reduce energy, come to rest. And the point of most rest on planet Earth is the center of Earth. And the poles, here's a pole, when it's spinning around the pole, where are you? You're up there. When you're spinning around the pole, except I am moving it, you got to get the idea, the poles aren't really going anywhere. People at the equator are in an area where theoretically time is moving slower because, according to Einstein, they're moving through space faster than somebody sitting at the pole. So an atomic clock sitting at the pole should be having a time difference between it and one sitting at the equator, simply because the atomic clock at the equator is moving at nearly 1,000 miles per hour. Well, the one at the pole isn't really going anywhere except through space with its inertia, with the planet, with the solar system. And our solar system is simply a tornado with inside a bigger tornado, which is a galaxy. And the reason it gets flattened out is going back to your basic ideas of flotation and buoyancy. If you imagine infinite universe full of really tiny who cares what, but it's fluidy to you, and it has substance, and electrons and protons and neutrons can float in it, and they are subject to exactly the same laws as flotation and buoyancy, everything starts to make sense. If you watch a log, a really, really big mother of a log, and a smaller log going down in a stream, they are going at the same speed, really. Let's not get finicky here. Oh, the stream is different, If it was in a scientific experiment shoot and you had a big barrel and a little barrel and they weren't too close together to cause wave disturbances, they would go at exactly the same velocity that the water was flowing. They wouldn't go faster than the water was flowing, and they wouldn't go slower. They would go exactly at the same rate that the water was flowing. So gravity is, if you want to think of it as pull towards the center, you can, but it isn't. It's really push from without. You're trying to get to the center of the planet and you encounter the surface. That's why gravity will be greater on a larger planet than a smaller planet, because the velocity on the surface of a larger planet will be greater whether or not the planet is turning quickly or not, because relatively it'll be going quite fast even if it seems to be going slow, because it's so effing big. That may not make sense to you. Size and time, size makes how you see time relative, and the smaller you are, you need to start using shorter and shorter and shorter intervals of time. But let's get back to the motion, just because I don't want to go on forever, and I've already gone up to 19 minutes. I'm trying to tell you that gravity is nothing more than solid objects reacting to the electromagnetic forces all around them, and the forces are trying to squish you together, not suck you together, because if you got to the center of the planet, where's the attraction? If an elephant, or if a boxcar and a Volkswagen are dropped from a roof, you forget about air resistance and all that. Every physicist will know they will both hit the ground at exactly the same time. How big they are had nothing to do with how much attraction there was between the Earth and the object. So that clearly has Size has nothing to do with it. It's where you are in space. The only difference your size is going to make is how much impact you make. The bigger you are, the harder you fall. That's all there is. So the splat will be bigger, but the velocities will all be the same. Everybody will die at the same time. Bye-bye. So what sort of motion is going on out there? Because I don't want to go on forever, and I usually do it up to 20 minutes already. I want to get into your mind I was talking to you about the fact that, the Earth, I think I did, that the Earth is traveling with the sun through space. And the Earth is traveling south pole forward, as is the sun, and it's making a giant wave, and the wave is 7 billion kilometers long. It has a period of 365.25 days. It makes no sense for the galaxy is turning and it's taking the solar system with it. So there is no real circles happening. That's just because the way how you're viewing things from Earth and the sun. The circles are all just in your head. The actual path of Earth through space is a wave. It's a helix, and it's a helix 7 billion kilometers long, and it is has a period of 365.25 days. And things like gee, I hope I didn't lose it. I think I lost it. Things like Saturn, when you see Saturn's rings and all that, it's the same as a shock wave. Damn it, I lost it. If you watch it, I had a picture there and I lost it. A jet aircraft going through the air, at the moment it breaks the sound barrier, you'll see a cloud, a mushroom shape form around it. The same thing happens with Saturn. As Saturn is flying through space, the particulate that's around it is being forced into a shock wave that looks like rings as Saturn flies sideways through space. And now I got to find it for you, because you know what happened is this is the second time I made this video, but the first time I ran out of memory, and I'm doing it the second time, and no two are the same. When I make a video, I'm just doing it on the spur of the moment, and of course my book is hard. I had it bookmarked and now I don't. Oh, here it is. So this is what I wanted to show you. Like when a jet, this was taken by a young ensign aboard, I think the Kitty Hawk years ago, of an F-18 breaking the sound barrier. You get the idea. Below it is a stealth bomber, and the stealth is so well built, it makes sort of a sphere around it as it breaks the sound barrier. But the thing is, if you imagine the F-18 and you view Saturn going through space sideways, you should be able to, if I get this right, catch the similarities. Observational bias of how we view things tends to make us see what we want to see, and what we're seeing, that's why magicians are so successful, is we're not watching what they're doing. But I'm going to wrap up here shortly. Gravity is motion, and the objects of space trying to find rest, following the laws of buoyancy and flotation, where there is no up and down is determined by the predominant spin around you, the forces. Gravity is motion. Now, just because I don't want you to believe that I made this up about the fact the Earth doesn't really make circles, and it really makes waves through space. Way back in 2004, when I was first studying this, I wrote to an astrophysicist at Cornell University, and I'm going to read you. This will be the last thing I've done, because now I've gone really, really long, and I didn't intend to. But I'm going to read this. It's from Cornell University. And my question was, since the sun is revolving around the Milky Way, does that not mean that the Earth is moving through time-space in a wave pattern? I.e., By the time the Earth moves around the Sun, will not the Sun have moved so far through space-time that, in fact, it, the Earth, is following a path through time-space which is more of a sine wave pattern? And I mentioned I was moving around because I was homeless at the time. And she answered back, I'll skip her answer about that. The question is, though, is the Sun moving fast enough in the galaxy to make the Earth's path wavy, or will it loop around on itself, or make a circle? I'm saying it doesn't make a circle. It does not loop around on itself. It can't. That's why gravity happens. The Sun goes about 230 kilometers a second around the center of the Milky Way. So in 1 year, it moves roughly 7 billion kilometers. I didn't make up the 7 billion. This is from Cornell University. The Earth orbits the Sun about 140 million kilometers from the Sun. The distance, 93 million miles. So the Earth is, this little teeny object is almost on top of the Sun, only 93 million miles away, 140 million kilometers. I'm going to get back to reading this. The Earth orbits the Sun about 100 million kilometers from the Sun, so you can see that the Sun and the rest of the solar system moves much further than the distance between the Sun and the Earth. She's saying the distance this Earth and the Sun move is way farther than the distance of the Earth from the Sun. Getting back to this. So the Earth's net motion through the galaxy, and that's not even counting what the galaxy is doing. It's moving too, and who knows where. So the Earth's net motion through the galaxy is an extremely stretched out wave, being about 50 times longer than it is wide. So I didn't make this stuff up. So if you can get down to imagine that you're just this tiny bit of space dust, not so different than this ball, and we are all wrapped up like the flotsam and gypsum of space. We are solid electronic beings. We are constructed of electronic beings. So we are both magnetic, and we are responsive to these zillions of magnets that are flying around out there. We're made of them. Everything we do depends upon electrons. Electrons are the powerhouses of the universe, and they're trying to get away from each other. Sometimes they form stable relationships and come to rest as matter, as a standing wave, because they're so strongly bound. Sometimes they're a bit looser, like the gases in the air, but the gases, you wonder why the gases don't dissipate off into space. Well, the gases of Earth are being pushed against the planet by the pressures of dark energy, dark matter, which I say are gamma, and the gamma, which I say electrons are made of, even they are probably not the smallest particles. The gamma are probably made up of even smaller things. You could take the tetrahedron and fractal it to as small as you want to think it can be, and I see no reason why under pressure you couldn't, just like you could under the right amount of electronic pressure, crush an electron out of existence and turn it into gamma. There's no reason why you can crush gamma down to where is nothing. The thing is, at the level of nothingness, time is occurring, it would seem to be happening so quickly that the rest of the universe out there would seem to have stopped. I don't know if that made sense to you. So now I'm up to nearly 30 minutes. I'm going to shut up. Gravity is push, not pull. Nobody has any idea what causes gravity. You don't have to believe me. Ask a physicist. No, we don't. We don't know. We can tell you how it works, but we don't know what causes it. And I'm telling you, it's just a response to the physical and electronic motion of the universe. Everything is trying to find rest. If you watch a stream, everything wants to gather up in a spot in the stream where there's the least motion. That's what's going on out there. All those suns and stars, they're trying to group together to swirl together, and that way, relatively against the speed of light universe, they use less energy and move slower. But everything decays. Don't believe a lot of what you hear. There's a lot of theory out there that is not fact. A lot of commentators, aside from me, who are just, even from Stephen Hawking. Stephen Hawking was a mathematician, and he went down the road of taking that certain theories were real, such as Big Bang, and then did the math, but it didn't work out. That's why he didn't get a Nobel Prize. And then the idea of black holes fell apart when we realized that even black holes are impossible. Black holes spit stuff out at the poles, in case you didn't know. I'm up to 30 minutes already. Shut up, David. My name is Butch. Look me up. I'm old. I'm not at all shy, but quite reclusive. I consider myself living on a planet of ignorant barbarians. The humans terrify me. Bye-bye from Butch.